Hi guys, welcome to Intelligence Lectures. Today we'll be looking at number patterns. So if you haven't subscribed, please hit on the subscribe button and also the notification bell so that you'll be notified every time I upload a new video. And also follow me on Instagram, it's Intelligence. And you can ask any question you want to ask over there, and then I'll try my best to answer you as soon as possible. So today we'll be looking at number patterns, as I already alluded to you. So um, number patterns. Number patterns, we have two types. Okay, today I'm gonna look at two types of number patterns. Namely, I'm gonna look at the linear. I'm gonna look at the linear and the quadratic. I'm gonna look at the linear and the quadratic, but I'm not gonna spend too much time on them, especially on the linear. So if you have any question, you can ask me, or if you need a video that will specifically be focusing on the linear part of number pattern, I'll be more than happy to create it and to help you guys as we're busy moving forward. So without any waste of time, let me try to simplify the linear number patterns. So the linear part of number patterns, it's very simple. It has the formula Tn is equal to Bn plus C. Okay, this formula is is uh, is taken out from a quadratic formula of number patterns, but it simply means that this Tn is the term number. It actually means the term number. So for instance, let me just say you need to find the number which is at term 100. Let me just say you have a set of numbers, and then as you can see, this is number 1, number 2, 3, 4. Let's just say you need a number that is on position 100. So it means you're just gonna say T 100 because the term number is 100. So you need to find the number that's sitting on position 100. Yeah, that's as simple as I can define it. So Tn is the term number, and then this n here is simply means that you're just gonna replace this 100 over here. It's like the n is for the number. So if you are looking for a number that is sitting or is placed at position 100, then it means you're just gonna say T 100 is equal to B 100, like you multiply B by the 100, which is the 100th term. So you multiply it by the B and then you plus the C. The B in this case is a number. B is a number that is let me put it like this. B is the number of the that is found when you are doing the first difference. We're gonna understand this as I'm busy explaining it, and yeah, but this is the first difference. This is the number you're gonna find when you're doing the first difference. And then C, you're gonna think. Here you have to think, what can C be? So yeah, I believe now everything is a bit difficult, so let me try to make them less difficult. So let's say now we have a number pattern. Let's just say we have 5. Okay, let me start with let's say now we have 0, 5, 10, 15. Yeah, and then we have to find the first difference. We have to find the difference, like we have to find how much do we add or subtract to the pattern to get the next number. What I'm saying is, if we have 0, we have to find a number that we can add or subtract on 0 so that we can arrive at 5, which is 5. So this is very simple, because if you have a calculator with you, you can do it more simpler. So it's easier to use a calculator. You just say 5 minus 0, which gives you 5. Then you know that you add 5. You add 5 to the 0 to arrive at 5. You add 5 to the 10 to the 5 to arrive at 10. You add 5 to the 10 to arrive at 15. This is the difference we're talking about. It's the first difference. So when we deal with linear equations, we only have the first difference because it's linear. You're going to understand when we talk about the second difference when we get to a quadratic formula. So like I said, b, okay, let me write it here. This is b. This here is b, because I said b is equal to the first difference. This is b over here. So no need to complicate things. C is what we're gonna find. So if ever we have to find a formula, because sometimes they can say, okay, find 1, 2, 3, 4, the fifth term. They can just say find the fifth term. Then you just have to add 5 to the 15 so that you can arrive at 20. Simple. Let me do this to separate them. Then you arrive at 20, and then that's as simple as it can get. So now let's just say, now they said find the Tn. So the nth formula, or whatever they can call it, but Tn. So now you know that the general formula is Tn being equal to Bn plus C. This is very simple if you're following up to this end, because there's a lot of things we're going to cover. So now you have to find b. B obviously is going to be 5. It's going to be the first difference. As you can see, it's 5. So b, our b, it's 5. So if you can say Tn is 5n plus c, then you start replacing here, and you say, okay, as you can see, there's 0 over here. This is the first number. This is the first number. This is the second number. This is the third number, fourth, and so on. Let's just say it continues, and then you're gonna have the fifth, the sixth, and so on. So now we have to find C, and then we know that if we say 5, and then we replace n by 1, so that we can get the first number. That's why we're putting 1 here, because 0 is at position 1, and then 15 is at position 4. So for instance, let's just say we use 0. You can use any number, so I'll show you. So let's just say we use 0 is at position 1, and then we say 5, and we put 1 because it's we are using 0, which is at position 1, and then what do we get? We get 5. So this tells us that we can't say Tn is 5n. So what can be C? C can be minus 5. So that when we say when we replace on the formula, it's gonna be a bit simpler, because now we're gonna say minus 5 because of the C. Then this is equal to 0, because 5 minus 5 is 0, so we arrive here. So now let's look at 15, so that we can prove that this formula is right. Now we're gonna say, let me not make things a bit complicated here. Now we're gonna say let's just say now we have to find 15. because now we've seen that if we say Tn is equal to 5n minus 5, then we're going to arrive at this 0. We're going to arrive at this 0. So now let's just say we have to arrive at 15. And then we're going to say 15 is at position 4 minus 5. And then you can use your calculator, say 5, position 4 minus 5. We arrive at 15. Then it means this is our Tn. So now with this being said, I think you can solve any linear equations, because if you find this equation over here, then it means you can find any number that is needed on this set of numbers. So let me put it a bit simpler again. Tn is equal to 5n minus 5. This we found this because we said b is equal to the first difference, and c is equal to what we found, and then we try to manipulate it so that we can arrive at the sequence itself. If ever we didn't have this one, the minus 5 over there, then it means we were not gonna arrive at 0 or 5 or 10 or 15. This one describes this set. So now if they say find which, okay, let's just say we need to find 15 using this formula. 15 is at position 4. Then it means now you're gonna say at position 4, we have the term at position 4 is described as 5, position 4 minus 5, which you will arrive at 15. Now let's say now we need to know if 15 is really at position 4. Then we're gonna say the term number, which is 15, you're gonna replace it there, is equal to 5. Now we need the n, the position, because here as you can see, we replaced the position on which 15 is situated, and then now we need to find out if really it is at position 4. Then we're just gonna say n minus 5. We all did solve for x and all those kind of things. Then this 5 will cross over here, and then will be 20 equals to 5n, and then you divide by 5. Then you arrive at n being equal to 4. So this tells us indeed this formula describes this set of numbers. That's linear patterns. You just have to find the first difference, which will make you arrive at the Tn, and with this Tn you can find everything. So if you have a problem finding the Tn of a linear equation, you can ask me a question in the comment section below, or feel free to send me your question on Instagram, and I'll try by all means to answer it. So without any waste of time, let me move to the quadratic number pattern. So the quadratic number pattern is described as Tn is equal to a n squared plus bn plus c. Now you can see this is the linear, so it has been derived from the quadratic, like I said. So that's the linear, this is the quadratic formula. It describes the quadratic formula. So this one I'm not gonna explain it a lot, but I'll make sure that you guys understand. So let's just say now we have a formula, a set of numbers, a pattern, which is, let me just take 4, 7, 14, 25. Let's just say we have this set of numbers, and then now we have to find, okay, let me make it simpler. these are some tips when it comes to number patterns, use quadratic number patterns. The first one, you have to find the first difference, and then the second one, you find the second difference. You find the second difference. These, whenever you see a quadratic formula, a quadratic number pattern, try by all means to find the two, no matter how complicated, difficult, or complex it can be. Find the first difference and then go on to find the second difference. So now in this formula, we're gonna find the first difference and then the second difference. So it means now we're gonna say 7 minus 4 is 3, and then 14 minus 7 is 7. 25 minus 14, it's 11. It's 11. Let me confirm. 25 minus 14, yes, it's 11. And then from here, this is the first. This is the first difference. As we all know that in maths, when we say difference, we mean, subtraction. So this is the first subtraction, when we subtract the second term with the first term. So this is the first one, and now we have to find the second difference. Remember the tips. And then we're just gonna say 7 minus 3, it's 4. 11 minus 7, it's 4. The second difference is always the same. The second difference is always the same. This one is the second difference. So this second difference is always, if it's 4 here, it means they're gonna be 4 all the way. If it's 1, they're gonna be 1 all the way. So this 4, you're just gonna have 4 using the second difference. So I'll have to erase since it's a small board, but I'll try by all means not to erase the important parts. So now we did this. Now let's just say, okay, now we have to find the Tn. To find the Tn, we need to understand a few things. There are a few constant formulas which we use to find the quadratic Tn. So these are always, we are using these numbers. The first one on the original set of numbers, and then the first one on the first difference, and the first one on the second difference. But it doesn't matter on the second difference because it is always constant, but we are using the first ones. So if we are using the first ones, we know, okay, there are 3 constant formulas which you have to remember every time. You have to memorize and know. So we have A plus B plus C. So A plus B plus C is equal to the first number on the original set of x's being given to you. This is how we do it. That's the first formula. The second one is 3A plus B is equal to the first number on the first difference. The first number on the first difference is equal to 3A plus B. And then the last one, we have 2A. So 2A is equal to the first number on the second difference. So you can just say it's equal to the second difference. It's okay, because the second difference is always constant. So this is how we do it. Now we have to find A, B, and C, so that we will be able to define our Tn, which is an squared plus bn plus c. So to make things simple, let me try to erase this part. So now, since we have this, okay, myself, I like starting where things look a bit simpler, and I advise you guys to start with this one because it's a bit simpler to solve and you can find answers right away. So now you're gonna say 2a equals to 4. This is what we know. And then we have 3a plus b equals to 3. That's another one. And then a plus b plus c equals to 4. That's the last one. And then now, let's first look at this one. This one we can just say divided by 2, divided by 2, a is 2. Then we found a. And then now, we're going to look at this one. We need to find b. And then we just replace a by 2 and say this one plus b is 3. And then this one is 6 plus b is 3. And then b is 3 minus 6, because this 6 will move on, will cross over the equal sign and it will change its sign, and then it will become a negative, and then it will be 3 minus 6 being negative 3. And then when we come here, we have to replace a, we have to replace b to find c. And then now it means that since we have a is 2, and then we have b is negative 3, and then now we need to find c equals to 4. I don't know if you guys can see what I'm doing here, but okay. And then now it's just gonna be, as we know that a positive multiplied by a negative is a negative, then we have 2 minus 3 plus c is 4. And then 2 minus 3 is minus 1 plus c is 4, c is 5. So this is how we do it. And then when we come back to our formula, we're just gonna say if this board is too small, let me erase. You should memorize that a is 2. So yeah, a is 2. So when we come to this formula, Tn is an squared plus bn plus c. Now you have to know, a is 2. So because I erased it, then Tn is equal to a, it was 2 n squared plus our b negative 3 n plus our c 5. Then we're gonna have Tn as 2n squared minus 3n plus 5. This is our Tn, which means this formula describes this set of numbers we have here, this pattern we have here. So it means now, if you have to find 7, let's just say we don't know where 7, let's just say we don't know that in position 2 we have 7. Let's just say we don't know that, and we need to find a number at position 2. So you're just gonna say Tn, let me try to erase these parts. So we're just gonna say T, the term number, which means it's term 7, term 2, because 7 is on the second position. So T2 is equal to 2 squared minus 3, 2 plus 5. If you can punch this, we should get 7. Let's see. 2 squared minus 3, 2 plus 5. We get 7. So now it means that if we found this equation, we can do everything with our pattern here. Now we've seen that in on position 2 we have 7. Let's just say we don't know that where 25 is. Let's just say we don't know where 25 is. So now if we don't know where 25 is, it means now we're just gonna replace 25. Like now you're just gonna say 25, because it's the term number. It's 25 being equal to 2n because we want the position where 25 is. N squared minus 3n plus 5. So after arriving at this point, you're just gonna use the formula, okay, let's just do it. And then this one will cross over the equal sign, and then we're gonna have 2n squared minus 3n plus 5 minus 25 is minus 20. To confirm, it's 5 minus 25, it's minus 20. So from here you can use your quadratic formula, or you can factorize, but I like using the quadratic formula because it's more simpler.